Today in class, we learned how to use Boyle's law, Charles's law, Gay-Lussac's law, and the combined gas law. The examples that we did in the notes today, we did examples 2, 4, 6, and 8. But I want to go back here in this little video lesson and let's work out the ones that we skipped. Let's look at number 1 first. This again is from your notes examples, just to give you a little extra practice in case you need it. Number 1 here says you have a balloon that contains 30 liters of helium gas at 100 kilopascals. What is the volume when the balloon rises to an altitude where the pressure is only 25 kilopascals? So let's label our givens. So we see 30 liters, and 30 liters is a volume. We're going to call that V1. 30. Notice there's a decimal, so that means it has 2 sig figs. Then it's at 100 kilopascals. That's a pressure unit. And there, notice the 30 liters is at 100 kilopascals, which means they go together, P1 and your V1. So 100 kilopascals. Also take note, y'all, there's no decimal on this number, so it only has 1 sig fig. Question says, what is the volume? So we're looking for V2. When the balloon rises to an altitude where the pressure is only 25 kilopascals. So P2, they're giving you 25 kilopascals. So imagine you have a brand new helium balloon, you go outside and oops, it escapes and it goes into the sky. You've seen them floating, I know. So when it rises in altitude, y'all, the pressure is going to change, so it's going to affect the volume. All these things are interrelated. So we're looking for V2. Since V1's in liters, V2 is going to be in liters. The next thing is to figure out which gas law we need. This has just got P's and V's in it, so we're going to be using Boyle's law. Remember, that is P1 times V1 equals P2 times V2. Always show your formula, class. Now, double check your units, make sure they match. The volumes are in liters, the pressures are in kilopascals, so you're ready to rock and roll. Just plug it in to the formula and then plug it into your calculator. Do the algebra. So P1, you're going to plug in 100 for your pressure. V1 was 30 with a decimal. P2, 25. And V2 is what you're looking for. You're going to isolate your variable, which means we need to divide both sides here by 25. Divide by 25, divide by 25. That lets it cancel here. Notice how we've isolated the variable. I'm going to go ahead and write the V2 on this side, but we're going to isolate the variable. So now you're going to multiply 100 times 30 divided by 25. Now on your calculator for this one, you get 120 liters, but we got to round it to proper sig figs, class, so don't forget that. Sig figs are important. Go back and look. We have 1 sig fig, 2 sig figs, 2 sig figs. So we're going to round our answer to 1 sig fig. Now, this one, when you round it to only 1 sig fig, that means you're rounding it right here. Notice you look at the 2, and the 2 is not going to round the 1 up. So you're going to round this to 100 liters. That's your final answer. Okay. All right, that's number 1. Let's go on to number 3. Careful on these, y'all. Use your context clues. It says calculate the final volume, which means V2 is what we're looking for. So pay attention to your context clues. When 75 milliliters of a sample of gas is heated from 5 degrees Celsius to 60 degrees Celsius at constant pressure. So let's label everything. 75 milliliters will be called our V1. 75.0 milliliters. T1. Notice it says it's heated from 5 degrees Celsius to 60 degrees Celsius. So this is our first temperature that corresponds to that first volume. So we're going to label T1 as 5 degrees Celsius and T2 as 60 degrees Celsius. And V2, again, is what we're looking for. There's my question mark, and it's going to be in milliliters since my V1 is in milliliters. Now, if you wanted to convert it to liters, that's totally okay, but just make sure your units agree. Now here, even though both of these temperatures are in Celsius, we cannot leave them in Celsius. The gas laws require you have to convert it to Kelvin. So that means we need to add 273 always to our temperatures. That's going to give me 278 Kelvin here. And for my T2, it's going to give me 333 Kelvin. Ready to plug into our formula? We're going to decide whose formula we need. We see T's and V's here, which means it's Charles's law. And the formula for Charles's law is V1 over T1 equals V2 over T2. There's the formula we're going to use. Let's plug into that. V1 is 75.0. T1, 278. V2, that's my X, so leave it your variable. You can call it X if you'd like. And 333 is our T2. All right, so we need to rearrange and solve for X. Now remember, at this point, if you can go straight to your final answer, go for it. But we got to cross multiply, so that means that 333 has got to be coming up on this side. So when you rearrange that, you end up with 75.0 times 333, and leave your 273 down. We need it left on this side, and that will get your V2 all by itself, which is what you want. So multiply 75 times 333 divided by 273, and that's going to give us our V2 of 89.8 milliliters. Okay, 3 sig figs all the way across, y'all, so we round this to 3 sig figs. All right, finally, let's look at number 7. This one says you have a sample of gas that occupies 75 milliliters at 725 millimeters of mercury and 18 degrees Celsius. Calculate the volume at 800 millimeters of mercury and 298 Kelvin. So we're going to label our givens. This is a combined gas law formula. It's got everything in it. So 75.0 milliliters, that is a V1. We need to label it as a volume. It's the first volume. The 725 millimeters of mercury is at that same situation, so we're going to call that T1. And 18 degrees Celsius, that's going to be my T1. Add 273 to that, and that's going to give us, when we add 273, 291 Kelvin. Okay. It wants us to find the new volume, question mark, and this is in milliliters, so that means the V2 is going to be in milliliters unless you change it. At 800 millimeters of mercury, that's the pressure, that's the P2, and T2 already in Kelvin. Alrighty, so 298 Kelvin, so you don't have to convert that. Both temperatures are in Kelvin, you're good. Both pressures are in millimeters of mercury, you're good. The volumes are in milliliters, so we're ready to plug in. Let's write our formula. P1 V1 divided by T1 equals P2 times V2 divided by T2. This is your formula. Always write that down once you label your givens. Now you're plugging into the formula. Plugging in P1, 725, V1, 75.0, T1, 291, P2, 800. That's 1 sig fig, y'all. Be careful with that one. V2 is your variable you're looking for, and T2 is 298 Kelvin. Okay? Cross multiply here. We need to bring the 298 up and cross the 800 down, and that will isolate this variable and leave your V2 all by itself. So we're going to have 725 times 75.0 times 298. Divide that by 291 and 800. We need to round it so that it only has 1 sig fig, because 800 has only 1 sig fig. There's no decimal. For your V2 here, you're going to end up with, let's see, my calculator says 69.6 milliliters, but we only want 1 sig fig. We're rounding it right here. So we're going to round it so it's 70, without a decimal, milliliters. And you're done. Great job, y'all.